Hmm. Ah, original tu. Ada dua. Yang kumeka. Cuma ya wonde.
But when we see the technology that is around us now is more advanced, and we have the negative and the positive what side of AI. So AI is just like something to make our work easier. So in my own field, I've done some writings with AI, which is very perfect. But just like one of the scientists said AI can do the work of ordinary man, but cannot do the work of extraordinary man. So because it's someone that is behind AI. So it's someone one brain is behind what? AI. So in my own field, even in medical field now, they have introduced AI to a lot of things, like the reception, the little laboratory techniques. They have introduced AI to it. For example, now let's say someone want to go for a surgery, particular for one surgery, let's say maybe tooth extraction, kidney transplants. They have some tools that when they put it in place, will tell us that for this particular source, this particular time, this person cannot undergo this surgery. Why? Maybe the blood is low, the temperature around the surrounding cannot support that kind of what operation for now, or that person have eaten some things that the surgeon will not know, and it still remain a few minutes for that thing to work, to digest throughout the body. So the AI will give a sign that so person remain like 1 hour before you can perform this particular surgery. So the AI is just like a tool to reduce human mistake. Number one, it's like a tool to reduce human mistakes. Then number two is to ease the task. So, and secondly, in copywriting, we have a lot of industries spending money on copywriters. Write so thing for us so that we can send it to our customers, and this will lead like lead generation to what? To get products from us. So many of these countries, like this industry like Amazon, they have been using AI now to what? To generate a lot of customers, addresses, telephone numbers. So what I can just say about AI is just like is to ease our tax. So and it can fit in any industry. Can fit in any industry. So let me just take a stop for now.
This old man, where are
Inshallah, next an hour or so, we'll take us to that session. Similar session.
In the last 10-15 minutes, I have gathered a lot of knowledge from him, from Mr. Hafiz and everybody. So I was even thinking maybe we should just share certifications for everybody and we should go back to our houses. Okay, it's good. Good afternoon. My name is Ibrahim, and first of all, the course we are doing today is not just AI actually, but understanding the journey. So we're going to take us through the journey and some techniques and everything. So in the beginning, it all begins with computers. Without computers, there will not be AI, right? Computers that would occupy this room would only be able to calculate maybe some few basic mathematics in the past. Then we are using relays for data processing. Relays still exist today. They are used to switch on our ACs and other stuff. But then it was used to turn on or off logics, where one will click in a particular direction, that is normally close, and 0 will click in the other direction, that is normally open. So as time goes on, they realize the massive need for a computer is massive, is expensive. It consumes a lot of power, generates a lot of heat, and it's very expensive to put together. In fact, only the government could afford a computer. So a new generation of switch was invented, and that is called the transistor. The transistor was a revolutionary component that took us away from switching mechanically and gave us the bright light of ability to switch automatically. What does it mean? It means that in the computers of the old, you would hear a lot of noises. When you send 8 bits of binary digits, you would hear 8 clicks. So you can actually count, or even with sound, say this is what the computer is doing. That was in the first generations. So, but now, with the invention of transistors, you can walk past a giga or massive size of computer and you won't even hear a sound. Whereas billions of logics are being processed, billions of bits are being processed. So a transistor, on the other hand, is a component. It's a kind of switch that is controlled by logic. It takes 0 and it gives you anything based on how it is wired. Then when you give it 1, it also gives you anything based on how it is wired. But there's only one thing, or there are only 2 options. It can either give you 0 or what? Or 1. And this is what we refer to as the basis of computing. So binary digits does not exist in the form we know it today. I'm sure everybody knows what binary digits are. Zeros and ones that we learned in the school. They are realistic numbers. They actually work in real life. They are not imaginary. They are not mathematical garbage. They actually represent turning something on. The way you will flip that switch and turn on your light bulb. And it represents turning something off. The way you will flip that switch and turn off your light. This is what binary digits means. 1 means on and 0 means what? Off. This number system was invented in order to be able to amass a whole complex of calculations into the system, something that was not possible during the time of release. With this, the transistor was so tiny, it was very small, so they could compress what would normally, contain an entire room into something small. So thanks to the relay, that gave us this miniature size of computers that we have today. Now, but that was not enough, because science will never stop. They continue developing. They continue reducing the size of the transistors. So the kind of transistor that was used is MOSFET, actually. MOSFET is a kind of transistor that works with voltage. So that's why the system uses power. That power is not just the power, it's doing a very critical part of the whole game. It's controlling the individual chips inside that processor that is in the system. So as time goes on, they realized that we could make these computers also reason. And this is where AI comes into place. AI is not a journey of 2 days, 2 years, or 20 years. It is something that was being conceptualized many, many years ago, about 70 years as far as I know. So today, it used to be philosophical. Back in the days, if you go to a computer science department, you'll be hearing AI, but it's philosophy. It's not practical. It's just something, an idea, a concept that they hope that one day some people will use it. The fortune we have today is that we are the generation that was able to implement it, in real time. So artificial intelligence is the intelligence that is inhibited by a non-life or lifeless object, an electronic device. You know, your computer has always been an electronic device from the beginning. So the reason why I'm taking this course is not because of any other thing. My name is Ibrahim actually, and I'm a student of Harvard studying tiny machine learning. And this is why I think for me to handle this course will not be a problem. So, okay, sorry. So what is the essence of my course actually? Let me give you an introduction. Machine learning is a sub-component of artificial intelligence actually. But why am I studying tiny? Because the future of machine learning is tiny. It used to occupy large systems in order for us to implement. But we are looking at a way such that in the future, what will normally occupy a very big space in terms of computing speed, energy, and everything can be miniaturized into something very, very tiny. And I brought you an instance of my ring. My ring here is a small kind of computer. It can transmit data, and it actually has some data in it. So the future of what we are discussing today is going to be something very small that you may hardly see it, but yet it's doing something that an entire community built into a system would not be able to process in the past. So, I'm sorry, man, something is not launching. I think I will need help. Okay. Sorry, please. Sorry for the break in transmission. Can we continue? Huh? Okay. So, so on this note, we are going to take some attendance so that at the end of the day, we'll be able to issue what we promised, only to those who came. And we are going to take our attendance. Since we are discussing technology, we are taught that the best way to teach tech is to implement tech in your teaching. So our attendance today will be in form of scanning. So I want us all to point our cameras to the screen, and you have a code in less than 5 seconds. Then we are going to scan this code. Yeah. Then on that, you are going to enter your data. And there's a lot to this QR. It is your license. It is your key. So I'll give us some few seconds before we proceed, because I'll be changing this slide and I'll be moving forward. You are going to use QR camera. QR camera. Once I move that slide, you won't be able to see that code again. You can go to Play Store. Go to Play Store. If you don't have QR camera, please go to Play Store. There's enough time. There's no camera of this one. Okay. It's what? Because I'm actually. Oh, yeah, can you push? Yeah, I'm about to see. That's scan. Q. Ah, I'm about to do this. Okay. She responses in schedule.
tó máa tó wá ṣe fún mi.
irọ́ nǹkan tó máa ṣe fún yín. Nǹkan tó máa wá sọ nǹkan tó máa ṣe fún yín. Ẹ one place to. Very good. I'm going to send the group. Please, if you cannot scan, just go to the group. You will see a link. Click on that link. Somebody has volunteered to help us. She puts the lever. Everybody, she can do it. How does she chapel? She is my 10 man. This enter your data. That's your registration for you. Will not get certification.
I've done it. I mean the next page now. Saying what is this?
It indicates that tomato show has buy is a must. You have to answer it. That's the name. So now, sorry. Before we proceed, there's a point you will get to. You may have to wait. There's a point you will get to in that form. You will have to wait. Why? Because the knowledge you are going to share will be needed to proceed on that point. So I'm trying to ramify my method of teaching, both visual and okay. Abuda. So there's a point where you need to answer some questions. The answer to those questions will be delivered during the course of this lecture. So if you are not listening, you'll be able to go ahead. If you come late, you'll be able to scan. So there's a lot of Abuda. Can we proceed? Please let's proceed so that it's a journey. That is where you may have to wait. So as we are discussing, you'll be picking your answers, then you can continue answering the. So we are continuing. So today we are going to begin with the theories. We are going to begin with the theories, and the structure for this course, you can see we are not covering much. There are just three things we are looking at. And the first thing we'll be looking at is the mechanics. The mechanics of AI. Everybody is shouting AI. I've used the AI. What exactly is embedded within that faculty of the tool that you are using? So at the end of this class, you will have understood to a very large extent, although it's very, very complex, but we'll try to explain as little as we can. So in the second topic, we'll be discussing prompt engineering. In fact, those are the two major things we'll be looking at, because the third one, which is Copilot, falls under the second one. Okay. So something is missing. Okay. So the mechanics. The mechanics are behind the system, the AI system, is what we are seeing on the screen. This is a list of, at least a corroborative list of what is embedded behind the scene of AI. So the first one is data. We look at data. We're going to talk about models. We talk about machine learning. We talk about deep learning. We are going to look at neural networks. We talk about transformers. Then we see the intricacies of LLM. Then we're going to touch inferences. Then we look at training in terms of AI. And lastly, we're going to see how all these things are combined together, how they work hand in glove to achieve the concept called artificial intelligence. So from here, it shows that artificial intelligence is not just a thing. It's a combination of several complex processes that comes together to work as a single whole. so we can enjoy the benefit of what they have come to offer. Now, what is data? Data is the foundation of AI. From the beginning, it was data. At the end, it's going to be data. It takes data as input, and it gives data as what? Output. So what it does primarily is the key that starts the engine of an AI is data. Data is simply a unit of information, and it is used by the AI either for training, that is during the course of training the AI, we are going to talk about that, it takes data, or for data processing, that is even when the AI starts working after the training, it still takes data. And likely, or also, it also gives data as its final output. We need to understand that there are different forms of data. So when we say data, today you will understand what exactly do they call data. Is it the 3 gig of data that we buy every day, which is what majority of people understand as data? That thing is not data. What you are buying is bandwidth. But this is not a networking class. So what data is what you are going to understand after now. Data can be in form of text. Your name is data. It can be in form of image. A picture of anything is data. We are discussing in terms of AI. A data can be an audio file. The way I'm speaking, it is being recorded. My voice, at the end of the day, will be passing through some series of machines before it gets to where it's going. Those machines don't understand anything we've discussed before except zeros and ones. So which means my voice will be converted to a series of zeros and ones, which is the only thing the computer understands. So at the end of the day, my voice becomes what? Data. Also, a video is a form of data. So these are what we commonly understand, and it is easy for everybody to understand this. However, there is still more to the concept of data. Data is wide. As simple as it sounds, and as microscopic as it looks, it's broader than we see it or we perceive it. Data goes into the concept of what we call data types. So when we discuss about data, we just send you a file and say, look at that file, it's a text file. I send you an image, look at that file, it's an image. And that's the end. But there's more. So a system, what it looks into is far beyond the actual content itself. For example, when I speak, what you are concerned about is what I'm saying. But once a system grabs my voice, it brings out a wealthy amount of information from what I'm saying. You can only see in one dimension of data. You are seeing what is written. You are hearing what I'm saying. Or you are looking at the video. And that's all. But the computers can see a lot of things. Can see up to 100 of different kind of data from that single data you provided. For example, my voice. The way I'm speaking, you don't care. You only care about the content. The computer cares. It's interested in the volume. And not just that, it's picking the pitch, the frequency. And there's a whole lot of things that can be picked from my voice alone, just by me talking. And that is going to take us to numeric data type. Numeric data type is a type of data in which the computer processes in a kind of way. The reason why we are looking at this is because the way the computer sees data from themselves is different. The way it sees a kind of data is different from the way it sees the other kind of data. So if the data is a number, the way computer grabs and handles number is different from the way it handles text. Numbers are called numeric, any kind of number you can think of. But in general, they are divided into 2 parts when it comes to computing. Numeric data types are of two types. We have the one we call integers. Integers are numbers that are whole number. 300, 500, 1,800. As long as it is integer, it's a whole number. As long as it's a whole number, it's an integer. Although there is still more to it. But let's proceed. The other kind of number we can look at from the computer perspective, they are called real, the real number. What's a real number? If you look at integer, if I say 3, it looks like it's complete. But that number is not real. Why? Because there is a very large possibility that there are some microscopic values behind it which we have overlooked. So it means that whole numbers are not real. Then the other kind of number that we call real they accommodate every excesses. So when you have a number, for example, 3, a real number is going to include 0.0. What does that mean? It's affirming that there is no decimal place. We did not round it off. It is clear that this number is 3.0. Do you understand? So if it is 3.00129, a real number will accommodate for that 00129 behind the dot. So the computer does not, if the computer does not take note of all these things, then our calculations will be rounded off. So if you say 3.29 plus 1.0, you can just get 4. It doesn't care. The computer has to care about those microscopic values, no matter how small, even if they are in the 100th place after decimal point. So those numbers are called real number. A real number consists of 2 parts, the mantissa or and the float. A floating point is the number behind the dot. So whatever comes after the dot is called floating point. So the next kind of data we are going to look at is categorical data. But before we look at categorical data, there's another kind of data, which is focusing on text. You see, text generally are called strings in the language of the computer. They are called what? Strings. A text or a string is a combination of characters, numbers, and every other thing, and symbols. So a string can consist of a number alone. A string can consist of letters alone. And it can also consist of a combination of the two. For example, your house address. It consists of the number of your house on your street. It consists of the street name, which is a text, all right? And it consists of comma and full stop, which are symbols. So that data type is called string. All these I'm saying, they are what the computer have to work on when you just send a WhatsApp message. You don't care. The computer is doing all this analysis in order to pick a data from one point and trade to the other point. This data, is it a number? Is it a text? Okay, if it is a text, or if it is a number, what kind of number is it? Is it numeric, or, sorry, is it integer, or what's the other one? Thank you, or real. So these are the things that the computer puts into consideration in the course of transmitting or even processing data. So the next category is categorical data. Categorical data, in terms of computing, is a kind of data, from what you can see, that is categorized. A kind of data that is what? Categorized. So a very good example is maybe a company organogram. That is clear, right? You have whoever you call them, then followed by, right? So that is an example. It shows that, okay, at this level, this and this and this are the people at this level. They belong to a certain category. Maybe we have 3 managers. So it means in the category of managers, there are 3 items. You know, so this kind of data are handled differently too. Why? Because the computer have to maintain the structure of their category. Do you understand? So also, categorical data can go beyond that, but let's proceed. Time series. Time series data are data that has timestamp. We should know, I don't know, some of us working in some certain fields, we have worked with this kind of data. Data that when you pick an event that occur, you have to record the time in which that event also occur. A very good example is your log when you get to work in the morning. You write your name and you put the time you come in. Is that not correct? So that kind of data, is it time series or not? It's time series data. All these are handled differently. Why? Because in the time series data, it has to handle the date and time along with the data itself. So that when it's making what we call inferences, we'll get it. It will be able to corroborate the two together. This person came at this time, this person came at that. So this person came late. This one came early. Okay, and there's a package for those who came early. You understand? So these are the computational whatever that goes on. Next is sensor data. Sensor data are data that are acquired from electronic sensors. A sensor is actually an electronic device that can communicate with its own environment. So an example of a sensor is a device that can understand one of the situations going on in the environment. For example, temperature. A temperature sensor can process information concerning temperature in a place. We have different kind of sensors for different purposes. We have humidity sensor too. Humidity sensor can calculate the amount of water in the air. There are other kind of sensors So I'm only going to pick those two. So these sensors, what exactly are they doing? They are agents, they are electronic devices that help in acquiring data that concerns this area that we have mentioned. So we have millions of sensors for different scenarios. We have sensors that monitor level of water. We have sensors that monitor temperature or whatever. We have sensors that monitor a lot of other things. So we even have sensors that monitors whether a place is occupied or not. You know, some of us have that in our offices. When you enter your office, the light is on. You don't care. You don't know what happens. There's nobody behind the scene. There's a sensor watching you. So once you say you are in your office, the light comes on. Now, there's more to it. It goes ahead and realizes that, okay, there is already brightness in the office, so there's no point turning on the lights. So there's a kind of reasoning along that line. But we are going to proceed. So structured data are data that have classes. So, for example, we can have mango, orange, coconut as a set of data. Then we have a cat, a dog, and a sheep. You can see that if you look at these two categories, each of them belongs to these different categories. This one belongs to the category of what? Food. All right? And this one belongs to the category of what? Animals. So based on this category, there is a way the computer also handles data based on that, so that in the future they can make inference, they can make deductions, they can make decisions. The next thing we're going to look at is models. What are models? A model is the actual thing that does the job of an AI. It is the brain that takes all the trainings. It is the one that does all the processing, although there's a whole lot of other components around the model. So in the future of this training, we'll be talking about, we'll be mentioning models and models. So models are the ones that takes the training, just like the brain, so that when the AI is trained, we talk about training later on, the models are the one that gets the skills. Borrow me the language. They get the skills, and these skills are implemented along other components in the AI system. So the model cannot work alone. It is useless. It's not like having your brain without the head. It's useless. So you need a lot of components in your body before the brain can actually do its work. So the next thing we are going to look at is machine learning. Machine learning is, there is something I didn't mention about model. Okay, we have discussed this data before. The way models do their work, to produce data in forms of, prediction. Prediction, you know what prediction is? They can take a previous event and make prediction that, okay, based on what happened 70 years, 80 years, 20 years, 10 days ago, and based on the series of events, it is possible that by tomorrow there will be rainfall. All these predictions, they are called predictions. They are based on previous knowledge, and that is because the model has been trained to monitor the weather for those previous days. These are one of the reasons why your predictions may not be correct. You see from your phone that at also time the rain will fall and it will not fall. It is prediction, it's not certain. Okay, the other classification, we have done that, and regression. So next is machine learning. I'm sure we have had machine learning several. Machine learning is the component that is responsible for experience. We have data, we learn something, but experience is another thing entirely. Experience is gathered during the course of work while you are using the data you have accumulated. So machine learning assists a model in transporting knowledge to it. So the model is the key. Machine learning is like the next shield, then followed by deep learning. Deep learning is a kind of machine learning that has massive amount of layers of processes before it gives the final output. It's like saying machine learning goes through a series of 100 channels or 100 processes before it does the job. Deep learning will go through a series of maybe 100,000. So deep learning is actually deep in terms of the way it is modeled. Some of these are algorithms. So these are the ones that are responsible also. Above machine learning, then we have deep learning as the further layer. Now, how do they learn? Through deep learning, they learn in three ways. It can be supervised. Supervised learning, remember that I said just the way the brain works. The brain is useless without so many other components. Imagine having the brain without your head, it's useless. Imagine having your head without the body, it's useless. So there are so many other components that encompass a model. So supervised learning is actually a process of teaching a model in such a way that the data is being supervised. What does that even mean? When you train a model, using a data that is already categorized. For example, when we have a lot of items, look at this classroom. We have toys, we have books. Then imagine that we pack everything together and mix them together. Then we want to teach a child what a toy is. We have to separate all the toys. Then we separate all the books. Now with this, I have assisted the child to a very large extent. So if I point my finger and say, those are toys, then he knows that everything there belongs to the toy category. That kind of learning in AI is called supervised learning. Now, unsupervised learning is the other way around. In the other way around, it means the data is not, the model is not assisted. Or there's a little bit of assistance. There's a little bit of assistance such that maybe the toys have been separated, but not fully separated. There are still some toys in the bookshelf. All right? So if I say, those are toys, then I'm leaving the remaining task for the child to come to the bookshelf and say, this looks like what is here. So this should be toy. Now, I have done half of the learning for the child. I'm trying to make the child, learn by him or herself by looking at another scenario. Now, the last one, which is reinforcement, that one, no data at all, no assistance at all. Everything is mixed up. So just go ahead and sort yourself. So during this process, you can see that the one that gives the best result will be the first one. Why? Because it is being supervised, right? This one may make error. You can have problems with that. It can give you rubbish. Next one we are going to look at, which is the next layer, is neural network. Sorry for my slide. There's a small error there. So a neural network is actually also a way in which one of the processes through which models are trained. They are a way in which the model gets trained in the same pattern in which our brain works. In fact, that is exactly where the names come from, neural networks. Our brain is full of water and neurons, then synapses. So neurons are those connecting cables. There are like billions of them in our head. They are what we call brain. Your brain is 70% of water. The remaining 30 are synapses and neurons and everything connected together. So this is exactly what they try to emulate. So they look at the human brain and try to design a system of learning that will allow the machine to learn in the same way the human process knowledge. And that result is called neural network. A neural network can be of 3 types or 4. But the one being used for training AI can be artificial neural network. Although there are other ones, we have the CNN, convolutional neural network, and we have RNN, recursive neural network. But we are not touching that right now. Then we are going to look at, transformers. What's a transformer? If I ask everybody what a transformer is, you know what transformers are. That thing that gives you light in your street. So that when that thing gets blown up, nobody has light. We are discussing AI here. And what a transformer is actually a system that transforms the input data into the output data based on features and characteristics of the input data. What does that mean? It means that the system can generate answers for your request. But how does it decide which pattern of answer it should give? It's going to look at which pattern of question did you throw. You ask a question, right? But in which pattern? So transformers are the one responsible for giving you back the way you gave it in. So let me say, for instance, is an Ijebu man, and he can speak English. I can also speak English. But in his English, there is still this ingredient of Ijebu in his intonation. So what Transformer does is that once he talks to me, I'm going to respond back to him using the same intonation, so that whatever response I give him will perfectly suit him. I'm not going to use UK tongue or US tongue. So I will not ask me, pardon, I did not hear you very well. So the essence of transformers is to give you a result that is based on your input. So you ask a question in a particular pattern, then it's going to give you an answer in that same pattern. And this is where prompt engineering will become extremely important. This is where we start understanding why prompting is of the essence. Okay, so on this note, I would love to hint us that it is this transformer itself that differentiates the model Chat GPT from other AI machines. And why? Where does that name even come from? If you look at the interface, you're actually chatting something, just like a WhatsApp. You are texting, and you're getting a response, as if there's a man behind the curtain. So what you are doing there is you are chatting, and that's where that name chat comes from. But what are you chatting exactly? You are chatting LLM. I'll talk about LLM later on. And the LLM is modeled using a method called generative pre-trained transformer. So the kind of transformer that it's using, it has already been trained. It is not trying to learn on the job. I don't know if you understand. So the kind of transformer that is being used by ChatGPT is not trying to learn from what people are saying. It has already been what? Fully trained. So it's pre-trained. That's where the P comes in. The first one is generative. Even though it has been trained, it can take from what it has learned and generate its own words. So GPT means generative pre-trained transformer. So it's not GPT, as some people will say it. So that name actually coins a lot of things in it. So it's explaining the kind of technology that is behind the brain that you are talking to. That is the man behind the machine. So large language models. So language models are simply a set of instructions that describes how a particular language, for example, is coined. Let me say, for instance, if you want to talk to someone, there are some certain terms that you have to watch out for. For example, if the person is your boss, if you want to say the same thing to somebody that is your colleague, you will not be as careful as when you were talking in the first place. Also, if I'm speaking English, I have to consider rules of concord, placing my verb where they're supposed to be, placing adjectives where they're supposed to be. So what large language models do is that they pick a language, Yoruba, and look at it. How do they form words in this language? Then this model is taught how Yoruba language is formed from its alphabet. So once it learns this, they go ahead, pick up Arabic, study Arabic, look at, okay, if a letter is coming in this way, it has to join, but if it's ending a word, it has to be in this form. So all these are what these companies went through, training their models massively. So a large language models means, think of any language on the planet, they have it processable. So their language models are very, very large. That, as far as I know, OpenAI has 178 billion of it. Think of that. 178 billion of different data in which they acquired while studying languages. Imagine Chinese. In Chinese alone, we have Mandarin, we have traditional Chinese, you understand? So this model is so large that it can take in your languages. In fact, while you are even expressing your thoughts in a language, don't worry, switch language. It will pick it and process everything perfectly without mistakes. Have you seen Chat GPT make mistakes in English? No, because it is running on LLM. Next is inference. Inference is simply the process through which a model draws conclusion. So look at this, look at this, look at this. Definitely this is this. You understand? So the method or the process through which a model draws its conclusion and says, this is what you are saying, this is what you want, this is your answer. And it is almost 100% correct all the time. Why? Because they have done also a lot of work in this. By studying, there's a process we call feedback. Feedback is when the machine is tasked to do a job, it does it. Then they check, okay, does it actually fit for as a response for the kind of input we have received? It fits, but maybe like 75%, so they have to go back again and tweak their models by touching the neural network, removing what we call load. I'm sorry, I intended to show you something. A network of how the neural network looks like. It's a kind of network. It's a strange network. It has what we call layers. So each layer is a precursor to the other one. They are all driving us to a conclusion. So for example, you throw in what's the color of the sky. It takes the keywords color and what? Sky. Then it processes those two keywords. Where does color belongs to? Okay, color belongs to a category of data that has to do with whether it is red, yellow, green, blue, whatever. So it drives itself into that domain of knowledge. It doesn't go everywhere. It just goes into colors. Then when it talks about sky, it looks at what does sky mean? Is it a car? So it looks okay. It is whatever. It goes into that domain of knowledge as well because it is categorical. We have mentioned categorical data before. Then it has limited how it's going to do its search, do its combination of terms, and so in that network, we are going to see all these things represented in what we call loads. So by my own field, what we do is that we try to make this load as small as possible so they can fit into something very minute and tiny. So the next thing we look at now is the last, I think. Okay, still have 3 steps to go. Training. Yeah, I've been mentioning training. During my course of preparing for this lecture, I intended to show us some things. I wanted to show us an example of a probable way in which AI models are trained. Training is the process of acquiring knowledge, right? How are models, how are they trained? Anyways, it's a process. It's a process of downloading the entire internet into one machine in a certain way. Imagine, Microsoft has 580 billion data in their Copilot. That machine is mad. But let's proceed. Once the training is done, you now look at, all these things were mentioned. Interconnected with themselves are what comes together to form that term we always say, AI. So AI is not actually part of the process itself. AI is never mentioned in all the process. AI is a name given to the complicated processes joined together to give us a certain result when we ask questions. So there usually used to be a kind of AI that we have before now. How AI works in this way. It works on prehistoric data. So it cannot give you something new. Once there is a request, it goes into the oceans of data that's already existing, looks for your response and give it to you. And that is different from, that is called traditional AI. That is how traditional AI works. But today, we have Gen AI, generative AI. What's the difference between traditional AI and generative AI? Generative AI does this. First of all, it has been trained. Remember GPT is generative pre-trained. It has already been trained. So it has a whole lot of knowledge. But what does it do? It can also give you a response outside the data sets of what it has been trained with. Because it is generative, it can generate from knowledge. If what you are saying belongs to the category of bird, then let me give you a picture. Look at this, is it okay? And if you ask you, are you okay with what we have, or I can still give you another one. That request is telling you that even though this answer is not directly in my books, I can give it from my own, concept. That is machine thinking at light speed. Now, this would take us to the next step. But before we go, I want us to know that I brought something actually, and I would love us to have an experience. But let me just proceed. So the next thing we are going to look at now is, before I proceed, please answer your questions. I've answered like 8 or 9 out of your questions. So go back to your form, answer those questions, and proceed. I have answered like 8 or 9 of your questions. Knows that the brain of a computer is the processor, right? And what's the full name? CPU. What's CPU? So now we are going to talk about what is the brain that processes all this AI jargon we have mentioned. Are they even existing somewhere like a hardware you can touch? Or it's just theories? So the next thing we are going to look at is the AI processing unit. When you talk about computers, at least some of us would, I had an experience during my service year. I was posted to a village where they've not seen a computer before. What they knew about computer was that thing they draw on the board. Wow. So the way computer sounds to them is the way AI sounds to some of us in the past years. But when you get to hold the computer and start working with it, then you start asking some questions. Sir, is this the CPU? Then you will say no. That thing you are touching, the CPU is still inside. Because one of the errors that was transmitted in our course of learning computing was the tell of us that box, we have the desktop, then we have the monitor. We have the desktop, that thing is called desktop. And we have the monitor. There are 2 types of the desktop. The desktop itself is called tall boy or flatbed. Dory. We have the tall boy desktop or flatbed. You don't want any flatbed. You don't want to tall boy. They are both desktop. The screen is the monitor. Inside that box is the CPU and other things that work with it. Now, for AI, we have seen that this system is a complex structure, right? Have your hard disk, have your RAM, network cards, all those things that you know about computers. Try to transport that knowledge into all what I've been saying too. The only difference is that the scale at which AI does its own processing is everything is different from how a regular computer does. The AI processing unit is actually a processor as well, just as we have our processors in our systems. But is there any difference in that processor and our system processors? Yes, there is. In the beginning, there was processors, right? Then gradually they started introducing softwares. Then there were softwares that were designed for graphics processing, such as rendering, such as 3D animations. These softwares were causing downtime on every other application. Once you start running them, such as Orion, such as other mentioned them 3D softwares, every other process will be locked. Why? Because the processor will not have enough resources to share around all this. While you're running a particular software, you can't even launch calculator. Why? To be dragging, that software has taken all your bandwidth, all your speed. So what did they do? They realized that the designer would want to use other applications while running their software, and they may not be using highly sophisticated systems. So what do? They realized that what was consuming the CPU time and energy and everything was the processing of the graphics. So they had to create another kind of GPU and CPU. So the computer now have a CPU for processing logics and numbers and everything. And we now have another CPU whose primary duty is to process graphics. These new CPUs are called GPU, Graphics Processing Unit. They don't concern themselves with applications like Microsoft Word. They don't have business with, but they are interested in anything that has to throw something on the screen. So that processing time and the resources are being handled by GPUs. So GPUs are more sophisticated. They are very, very sophisticated. They are so sophisticated that when you are running time-consuming applications, they take over the job and leave the CPU to rest. So when you need to run Microsoft Word, the CPU will do that. If you need to run your calculator, the CPU will do that. Every other simple applications are being run by what? The CPU. But the GPU handles heavy applications. So these GPUs have been developed over time. They kept developing them. Today they have become so strong. And in fact, most of the times, they are the cost for the high in price of our systems, the GPU. The GPU consumes a good amount of memory as well. That's why systems with good GPUs usually have very large memory, 8 gig and 16 gig and like that. Those systems are called machines. You know them. If you're an architect, you know what I'm talking about. So these GPUs were found out that they have enough strength. They have enough resources to handle all this data processing we have mentioned. So each company's graphics processing unit. So all these things we have mentioned, they realize that if you stack these GPUs together, stacking means mounting them on top of each other so that 100 of GPU can act like one. All right? So GPUs are the processors that processes artificial intelligence procedures and everything. So today I tend to show you that all I'm saying, they exist in touchable electronics hardware. They are stuff that you can see, you can touch and you can feel. But you won't be able to touch or feel them because they are not found or they are not created for common use. They are found in large server rooms, but they exist in real time. One of them is NVIDIA. This thing you're looking at is a very high efficient GPU. It has like 100 billion of, let me say, what a small GPU will do. I don't know if you can fathom what I'm saying right now. So they were able to cram something that should occupy large physical space into something as small as something you can hold in your hand. But they still consume. So they build systems around this to allow training. This thing was designed for AI. So there are hardware around it that allows it to take data, push it into the model, do the transformations, do all neural network and everything, all the algorithms. However, it is not only NVIDIA that is producing this. Although NVIDIA seems to be the most advanced product when it comes to this line. Next, we are looking at, this thing you're looking at here is the processor from Google. Google designed this for their TensorFlow. TensorFlow is a package for machine learning. And this is the device that does the running. So when you type something in your Google and you send, and you're actually running a machine learning program, it's going to one of these guys. They have like tens of thousands of these in a very large warehouse somewhere, processing all the data they are collecting from around the globe. So, but Google is not the only one in the game. You also have Tesla. Now, Tesla designed their own specifically for their driverless cars. They called their own Dojo. This is Tesla Dojo. It's a single unit as it is, but they have stacks. All these things I have shown you, they have been stacked in their data centers. And in a single stack, you can have like a very good number of them. Then in that data centers, you have columns, hundreds, thousands of columns of these stacks. If you have seen a network, what do you call it, server setup before, this will be easy for you to understand. So all these guys, they design these things for their own use, for their customer base alone. For example, this processor, what it does primarily is to take care of the need of every single Tesla car that walks on the street. So they don't need to come to your street and map that place first, so they can take it back to their office. As your car is driving, it's sending data back to this guy here. This is the guy that is doing the job of self-driving. It can drive itself, it can whatever. This is the guy doing it. So whatever the car is seeing, whatever it's feeling, whatever it's sensing, it's sending everything back to the Tesla data center. And this is the guy that takes the data and processes it at a very high speed, then send back. Okay, you can go forward. Turn right a little. Turn to your whatever. Okay, stop. You have parked very well. This is the guy doing it. So all these things I've mentioned are being implemented in real time. They are not vague. They are not ideas. They are reality. They are hardwares that implement them. So these hardwares are running AI completely. So we are going to, So we are going to stop here for a while. I mentioned NVIDIA, Dojo, a Grace Upper from another company. And this is an example of what I mentioned. Look at this stack. Each of this stack, take this cable for example. This is a slot. This slot is occupying an entire system in its own. Then we have like maybe 70 of them in this standalone. Then look at the column. You can have like 1,000 or 10,000 of these columns. Yes, or even more than that. I was able to see these things are very, very big. They are very big. So they are the ones receiving all your Chat GPT. How are you? What is my name? It takes that data from to one of these guys. You see a green light, blinking, processing or whatever, and send them back to you. So these are the systems processing your AI requests, your prompt. The next thing we'll be looking at is how do we now make requests from these machines. The concept of requesting solutions or talking to these AI systems is called prompting. What is prompt? Yeah, I completed my class. Okay, we have just completed introduction to the theories and concepts behind artificial intelligence. So I was tracking my presentation with this, but maybe some people did not notice. So after now, the next thing we're looking at is the practicality of the usage of these skills, which is prompting. I have still not answered your questions, don't worry. What is prompt? Mr. Hafiz, what is prompt? What's a prompt? A prompt. Okay. A prompt. Remember, I said in the beginning that the foundation of AI is data, which is needed in two cases: during training and during data processing. During processing, while it is doing its job, the job for which it was created, AI needs data in these two cases. But at the end of the day, it provides us with one thing: data as a result. So a prompt is simply a short text. I'm going to use text now, but I will change it later. I don't want to keep mentioning data. Because I said before that data can be in form of voice. It can be in form of video. It can be text. So that was why I said I'm going to borrow text So a prompt is a short text that describes or guides how a model should respond to a particular need. Please, there are key terms there. Guide. A prompt is a short text that describes or that guides how a model should respond to a request. What does that mean technically? It means that you are still the driver of the AI. That is where this is the critical part of the whole thing. The way you prompt determines the kind of answer you get. And that is why we go to the next one. Why we need to learn prompt engineering. Prompt engineering is a field that doesn't show you an exact formula actually. It is not as if there is 1 + 2 = 3 in prompt engineering, but gives you an overview of how your data structuring should be in order for you to maximize and gain maximum benefit from the system you are prompting. So there are 3 types of prompts. There are 3 types of prompts. The first type, which is the most common type, is called NLP, Natural Language Prompt. Natural language prompts are prompts that allows you to communicate with an AI model the way you are going to talk with your fellow human. Natural language prompt is a kind of prompt whereby you are communicating with an artificial intelligence model exactly the same way you are going to talk to a real human being. That is one type. It allows you to express yourself in however way you wish to express it. It allows you to detail your questions. It allows you to give examples. So it's only possible because of one thing. Why would a machine understand my need if I'm talking exactly the way I'm talking to a human? It's simple. It's because the machine itself is embedded with the faculties of natural language processing. The machine has a feature that allows you to understand the real human languages. It has been trained on human languages. So that is why you can also communicate with that machine in that language. Remember, we said a machine only understands one thing. 1s and 0. But this time around, you can talk the same way you are talking to your friend. Why? Because the machine has already been trained to understand how humans understand themselves. So this is the concept behind the first kind of prompt, which is natural language prompt. The second kind of prompt is structured prompt. A structured prompt, there's another name for it, I can't remember now. It's a kind of prompt that already have a specific output assigned to it. That is, if you use this prompt to, this is what you will get. So they are already named. They are named prompt. And this is one of the basics or basis of prompt engineering. What makes a prompt engineer different from any other person is because he knows these structures. He knows them. So whenever he needs them, he knows which of them to use at the right time. He goes to his AI toolkit, look at the situation on ground, and look at his structures, then fit a very good structure for his need. So that he will not be using a structure that is meant to create a table. You will be using that structure to draw a bird. Do you understand? So this is the second kind of prompt. The third type is conditional prompt. A conditional prompt is a kind of prompt that guides the model to give you a particular result based on certain conditions. For example, if the customer makes a request Then give them an answer based on the request. If not, greet them with a welcome message. Good afternoon, welcome to XYZ company. What do you want? That's because you have not made a request. But if you have actually sent a request, before the AI wakes up itself, there was already a waiting request. So the first thing, we will never greet you. We just give you a response. I'm talking about personalized AIs, where you buy API from OpenAI, Google, and whatever. They use it to model your own and create your own model based on your company data. So the language models that will be built around such AI will not surpass what you do in your company. You will be training your own AI with your own data sets. You understand? You will have seen from some websites, once you launch, one small box will come up. Papa, anything you want, ask me. Then when you ask, it will start giving you a response based on what they do in that website. So that model is running on a local data set. What's local data set? The data set that has to do with what you do in that small confinement, in that website. So it will be able to answer you anything outside what you do there. So next, we now look at what are those techniques that makes my prompt better and gives me more good results than his own prompt. So have you answered all your questions? Then you can click on that link. Eh? You are not following instruction. Yes, we are supposed to click a link. You have never finished, yes. But let's quickly answer that once and for all. We all know there is limit to everything. All right? In fact, if I continue to talk, maybe for the next, only God knows, I may break down. What does that mean? Even in AI, there's limit. Yes, there are 178 billion, 500 billion. There is still a limit to the amount of information you are allowed to ask at a particular point in time. This will allow you, I understood this very well during the time of Grok. Grok is the AI from Tesla. So you realize that as you are prompting, 400 million people are also prompting at the same time, sending their request to the same machine. How do we manage this so that the system will not choke? So there's a way to do it. There's a way to limit how much information the AI system can deliver at a time. So they introduce a currency that is used to calculate your wealth of data. Mr. Hafiz, I've not logged this since morning. I have logged this since 3 days ago. I have been talking to AI. He has not talked. He has more currency, he has more data that he can prompt with than me. Why? Because as a regular user, I have 4,096 of that currency every 24 hours. If you use everything once and for all, you have to wait the next day. So every morning, they give you that currency. You did not know this. That currency is called token. So you can spend your token as you wish. If you still have enough, you get it. A token is a description of the amount of characters or words that you use or spend during your course of conversation with the AI. It includes both your input prompt and also the response given by the AI system. So this data is calculated in what we call token. Every regular user on Chat GPT has 4,096 every day. But the moment you pay, they will double that for you. So you can access more, you can talk more, you have enough time, you have enough token, you have enough currency. So it depends on the kind of data you are requesting that determine how fast your token is being spent. And one of the ways you can minimize your token is to be a prompt engineer, so that in 1, 2, or 3 sentences, you have achieved what a regular person will spend a page. Not only that, by writing that page, he has spent a lot of his token. So the next time he tries to prompt, he says, sorry, I can't go beyond this. So instead of expecting a large response, you just get some few paragraphs, and that's the end. Why? Token has finished. Also, I'm already treating token management. So when you prompt, the type of data you are prompting also consumes or determines how much token you spend and how much token you have left. A person prompting only text is using less token than a person prompting pictures. I sent a picture, say, oh, Chat GPT, check me out. Am I beautiful? What you waste token? Or you say, create an image like that. An image consumes more token than text. A video consumes a lot of token than any kind of file. So a token is simply a currency that is used in the AI world to calculate how much data you have to prompt the AI. Please, if you have answered the question, go to the next whatever and click the link. We are going to be on the same page. Across the globe. Not even companies that are not even tech-based. We have machines running AI. I think Microsoft have launched a lot of products that assist companies to monitor in real time the state of their remote machines. So they will know whether something is jittering. Maybe like these companies that installs windmill. If you have seen videos of windmill, you can know they can be very, very massive. So, and they are far away from the town. So how will they know that something is going to happen before it happens? Because those things are extremely expensive. So they have hardwares. We have seen it that these things we have seen are hardwares. So they have hardwares, although in that case of machine, it's machine learning that does majority of the job. That studies the features around these machines and send report back. Maybe 2 days ago, everything was calm. But all of a sudden, this morning, the sensor started noticing a kind of vibration. So they will start monitoring from their back end that there's an increase in vibration. Maybe one of the blades is faulty. So where we are going is that artificial intelligence implementation, prompt engineering is not only limited to typing on your phone, on your laptop. In fact, I brought some hardwares that will confirm this to us. This is Quacky. It's a very tiny robot. It runs on AI. Quacky, yes. So AI is being implemented on hardware. I don't have to prompt it by saying anything. The way it works is different from all I've mentioned. It's called pre-installed. I already I've given it some instructions. So it needs some hardware in order to carry out those instructions. Like you need some cameras to see me, and amongst 100 people you can say this is me. So you keep following me. So it has data sets for faces. Do you understand? So we have other hardware too. And I deliberately brought Alexa. I plug in Alexa so that I can prompt it. It takes prompt, but not text. I will just speak. But it has wake up word. I call the name, then it wake up, listening to the next word. So once I give the prompt, it will give me a response. Before now, I can even make order. Alexa, I need a laptop. Which one? HP, Dell, or what? HP. So. And it will go to Amazon because I have connected my card. And the next day I will receive it. So AI has got to this level of automation where it doesn't only process your Excel worksheet or your PDF document or your images and everything. you can connect your entire house with, yes. I have this device here. How? I'll give you an instance. The light bulb in my bedroom, I can turn it on while standing here. How? I have told us that all those machines I showed you, a lot of them are in Florida, America, where they are Silicon Valley. That's where majority of them are staying. So whenever you prompt any AI, whatever, it takes your data down to that point. All those big machines you saw, we process it and send it back to the systems. So what I'm trying to show you is that AI is not only implemented on laptops or phones as text and everything. Machines are communicating with other machines. So if I say a word, this guy will take my word, send it to Amazon AWS, process it, then send back to it and give me a response in a split of a second. So, and that level of implementation has gone beyond just talking. It can even control real-time hardwares. A dummy fan, this fan is dummy. Why is it dummy? The control does not go beyond that regulator. That's it. With a device like this, I can make it intelligent with this thing here. So there's a way we feed data into this guy. We have talked about learning. I'm going to train this guy how this fan will understand my commands. Once it has finished training, I will pair it up with my phone. Then Alexa is already paired with my phone already. So the next time I need to on that fan, I'll just say, Alexa, there's heat. You may even question me, should I on the fan? Yes. If there was light, I would have implemented this because this device has already been trained from my home. Some devices have been trained on this guy. So you can turn on your TV by just voice. You can make some cues. It will not even be direct because it's AI, it's intelligent. You can say, oh, Alexa, there's heat. So what do I do? It can be conversational. Yeah, I already mentioned that. We have conversational prompt. You can make a prompt that will not just give you a response direct, but it can establish a kind of conversation between you, and it all goes to how did you form that prompt. So the way you form the prompt is going to, ignite that conversation. So AI is wide and it's in everything. So one of the major focus of my field is to make everything deploy on AI. So tiny machine learning is considering how even a book can be deployed onto this service so that every single thing can be tried. So I said something initially, I'll pass this ring around. This thing, as tiny as it is, it has some of my information in it. It can communicate with other systems. And I can make a lot of complex decisions around it. So AI is, when people do AI, this thing is beyond Chat GPT, whatever. Those systems you're looking at, they are touching many other areas that we don't even have an idea of. So the last slide was going to inform us that AI is beyond chatting. AI takes full control of things by themselves. Of course, they have been trained on what to do. They are called conditional prompts. They have already been prompted based on certain conditions. For example, if this thing vibrates so much, activate maybe a gyroscope. That is where you now see machine controlling machines. And it is that point that scientists are afraid of. That once AI gets there, we may be doomed. Yes, because they'll be able to take over, do whatever they can do. If they, yes, I can talk to you, I can discuss with you. They also discuss themselves. I don't know if you have heard his name, Isaac Asimov. I don't know. His machines were talking to themselves and they were making decisions. So they have become so trained. So all this AI, you are training it, it's intelligent. It's 4.0, it's good. Don't worry. One day they become wild. Yes. Yes.
I'm looking at the practical implementation of. Sorry, the question. So you want to, because again, I'm talking from how a system works point of view. So let's say we want to demo this, for example. You made an example of, again, I'm not saying if it will work like that. Maybe there are some other pre-conditions for that to work.
Of course, yeah. Of course, yeah. But go ahead. Okay,
so let's say this fan. Yeah. We know this is not a smart fan.
We want to make it smart.
Maybe you will make it smart in some. Now we have Alexa. This guy is going to be trained. So, assuming that this fan is like it's an analog fan.
It's analog. It's actually analog. So.
How would we make it? Can we make it?
Okay, actually, this part, yes, we can. Number one is this. It's very simple. Number one.
What are we going to do?
Okay, now I'm transferring from AI to home automation.
Yes.
So, home automation is simply application of all what we have been saying in the home. Imagine you talking to your house. Imagine you talking to your house. It's happening already. But this is a basic. This is a very basic one. This is one of the basic setup that you have to do. There's a lot of engineering behind it. A lot of wiring. For this device actually does something. It can communicate wirelessly. So because it is wireless communication, you have to first enable wireless communication for this fan. So all I just need to do is to install a IR module. IR module. So once an IR module is there, it means it can send infrared signals. This guy will beam infrared signal around the whole room. So as it is now, it is already pre-trained. Once it is 7 o'clock or so, there are some certain lights that will go on by themselves without my involvement. Then that program is not even running on this guy and it's not running on Alexa. It's running in one of the GPUs installed somewhere, not America now, China. So that's how it works. Application of these things means, from what you have said, preconditions. There are some preconditions. It's not just 1 + 1 = 2. There are some certain facilities that have to be in place in order for these things to work. So you can connect your gate to. Now, the question would have been funny 2 years ago. The question would have been funny 2 years ago. No. Yes. So we had a test late last year on, was it a pig? I think it was a pig. Yeah, it was a pig. So there's this chip, Neuralink, that installs, remember AI, neural network was designed to mimic how the human brain works. So a neural network chip or hardware can easily connect with that already existing structure. Why? Because they are running similar structure. It's a matter of connecting some of the wires to your neurons. For example, the neurons that deals with visuals, the correct, whatever, the one that deals with sound, and once you are connected, so your text will be turned into digital signals, and that signal will be transmitted to other machines, and they will understand, and they can respond back. What I want to change you have gone and joined your. Yes, so henceforth, once you reach that level, please stop addressing yourself as a human. Change your pronoun. My name is Afis and I'm a robot. That's what she's saying. So it's possible. It's happening. It has happened. What is not happening is massive deployment. It is still currently in the laboratory, but it has not reached massive deployment, but it's happening. And what is the essence? What was the reason why they did that? They realized the age of AI. AI is here, AI there, this one AI, that one AI. One day, what I mentioned may happen. These guys may become so intelligent that they are taking decisions by themselves. And AI may get angry and destroy your house. They walk away. So what they intended was, okay, they wanted to place human. That was what they said. But never trust them. They wanted to place human above all these machines. But you are a human being. You are not running digital signals. How can you not be above those machines? It's almost impossible. So you have to be there physically and turn off the switch physically. But no, they want you to be there always. So they install this hardware in your head. So if the AI is trying nonsense, you are hearing what they are saying. If they are planning, I have a video. No, I have a video on my phone of there's this delivery company. They have robots now that delivers directly to your address. So it's a very interesting video. So something happened one day. One was coming from where it has gone to deliver. The other one was just coming from the grocery store to deliver grocery. Now this is the problem. They met on a platform. It can only take one robot at a time. Did you know that they were talking and you can hear that sound, but you don't know what they are saying? You'll be hearing that sound, then they agreed. They were negotiating the road. It's on my phone. I don't know. Then one of them shifts back. After like 15 seconds discussion, you're like, this thing is happening in real time. It's not film. So it has gone to that extent. If you are using Chat GPT, from what that brother said the other time, if you have been following them from day one, you will notice a massive difference now. They are always improving. Right now, they're still working on. Imagine. The level they are now is not enough. They are still working. So they are working to make this thing perfect, but there's always a side effect. So the reason why they invented that hardware was to place man above the machine. But me, I said the reason why they designed that hardware was for them to have full control over everybody, so that they can shut you down if you do nonsense. You said, and they are the ones with the control. They have the remote control with you. They can erase your memory. In fact, one of the features of Neuralink is that you can download all your life experience of 30, 40 years and upload it into the cloud. So if something happens to you, down accident, everything, they will not help you download backup. Me, I know that is the mission. All this placing you above whatever, that's the mission. That's the mission. So very soon now, a human being will be walking on the street, that guy is connected to the internet. It's fully downloaded, so you can't hide. They are seeing you. Maybe now you can see hide under your mommy's bed. They just come and pick you like this. Why? Because there's a chip in you.
There will be a way to bypass the chips.
You break your head now. Oh, okay. Because they are placing it in the most fragile place in your body, your brain. Oh yeah, how will you have that? Okay, so you